أعزائي الطلبة، السلام عليكم ورحمة الله وبركاته. أهلا بكم في درس جديد من دروس الجيومتري Similarity of Triangles. If two angles of one triangle are congruent to their two corresponding angles of another triangle, then the two triangles are similar. What that mean? In the opposite figure we have two triangles ABC and DEF. If measure of angle A equals measure of angle D and the measure of angle B equals measure of angle E, then the two triangles are similar. Triangle ABC is similar to triangle DEF, and you have to write these two triangles in the same order. ABC similar to triangle DEF because measure of angle A equals measure of angle D and the measure of angle B equals measure of angle E. So if angle A is congruent to angle D and the angle B congruent to angle E, then triangle ABC similar to triangle ADF, and you have to mention the two triangles in the same order. A, it is the first letter, and D is the first letter. B, E, C, F. Question 1. Show which of the following pairs of triangles are similar. Write the similar triangles in order of their corresponding vertices. Here we have two triangles ABC and DEF. We have measure of angle B equals 80 and the measure of angle C equals 55. Measure of angle F equals 55 and the measure of angle D equals 45 degrees. So we have to calculate the third angle in triangle EFD. So measure of angle E equals 180. It is the sum of the interior angles of triangle EFD. So measure of angle E equals 180 minus 45 plus 55. It's equal 80 degrees. So this angle E equals 80 degrees. And then we have measure of angle B equals measure of angle E, each equal 80 degrees, and the angle C, measure of angle C equals the measure of angle F. So triangle DEF is similar to triangle ABC. Triangle DEF is similar to triangle ABC, and you have to notice that we write it in the same order. DEF similar to ABC because D is congruent to A and B congruent to E and the angle C congruent to angle F. B, we have measure of angle N equal measure of angle X, each equal 90, and the measure of angle M equals the measure of angle Z equals 25 degrees. So we have two angles in the first triangle equal the two corresponding angles in the second triangle. Then triangle LNX similar to triangle ZXY. We write it on the same order because measure of angle L equals the measure of angle Z and the measure of angle N equals the measure of angle X, each equal 90 degrees, and the measure of angle X equals the measure of angle Y equals 25 degrees. So you can say that the two triangles are similar. In this case we have two triangles XYZ and CAB. We want to calculate the third angle in triangle XYZ. So measure of angle X equals 180 minus 75 plus 65, which equal 40. So the third angle here equals 40 degrees. Okay, then the two triangles not similar, because we cannot find two angles in the first triangle equal two angles in the second triangle. Here is the angle equal 40 degrees, but we don't have any angle here of measure 40 degrees. With respect to figure D, we have AC is parallel to DB, so measure of angle A equals measure of angle B. Alternate, and the measure of angle C equals the measure of angle D, two alternate angles. So you can say that two triangles are similar. Also you can consider angle AEC equals the measure of angle DEB, vertically opposite angles. So we can write that measure of angle A equals the measure of angle B, two alternate angles. Measure of angle C equals the measure of angle D. For the same reason, the two angles are in alternate position, so triangle AEC is similar to triangle DEB, and you must write it in the same order. Example 1. In triangle ABC, D belongs to line segment AB. This point is belong to line segment AB, and E belongs to line segment AC, where DE is parallel to BC. DE, it is given its condition here, DE is parallel to BC, and the length of BD equals 1.2. The length of BD, where is BD? BD equals 1.2 centimeters, and the AE equals 3 centimeters, and the AC equals 4 centimeters. Where is AC? AC equals 4 centimeters. But from the given, we have AE equals 3, and 4 minus 3 equals 1 centimeters. We can deduce it. And DE equals 4.2. The length of DE equals 4.2 centimeters. First, prove that triangle ADE is similar to triangle ABC. Triangle ADE is similar to triangle ABC. We can prove it using these two angles, because we have DE is parallel to BC. Then measure of angle ADE equals the measure of angle B, because they are in corresponding position, and DE is parallel to BC. Also, since DE is parallel to BC, then measure of angle AED equals the measure of angle C. Then the two triangles ADE and ABC are similar. Second, find the length of each of line segment AD and BC. AD and BC. And we write, since DE, here is DE, always we back to the figure. DE is parallel to BC, and AB is a transversal. AB, straight line AB is a transversal to both of them, then angle ADE equals measure of angle ABC, and we can write angle ADE is congruent to angle ABC. It is the same meaning. Also, in the two triangles ADE and ABC, since angle ADE is congruent to angle ABC, angle ADE congruent to angle ABC, it's proved, and angle DAE here equals angle BAC. Actually, angle A is common angle between in the two triangles. So triangle ADE similar to triangle ABC, and we can deduce that since the two triangles are similar, then the corresponding sides are proportional. AD over AB equals AE over AC equals DE over BC. Then substitute. We don't know the length of AD, we write it, and the length of AB equals AD plus 1.2. Where is AB? Here is AB. The length of AB equals the length of AD plus the length of DB, and the length of DB equals 1.2 centimeters equals AE over AC. What's the length of AE? It's 3, and the length of AC equals 4. DE equals 4.2. DE equals 4.2 centimeters over BC, and cross multiplication here we have 4 multiply AD equals 3 multiply AD plus 1.2. 4 multiply AD equals 3 multiply AD plus 1.2 equals 3 multiply AD equals 3 AD. 3 multiply 1.2 equals 3.6, and 4 AD minus 3 AD equals AD equals 3.6, and this is the first required here. The length of line segment AD equals AD, and we use the second proportional. 3 over 4 equals 4.2 over BC. Then 3BC equals 4 multiply 4.2. Again, 3 multiply BC equals 4 multiply 4.2, and we write it here. So BC equals 4 multiply 4.2 over 3, and the result will be 5.6 centimeters. Question 2. In each of the following figures, prove that triangle ABC is similar to triangle ADE. Then find the value of X. Solution. First, you can say that since DE is parallel to BC, then measure of angle ADE equals measure of angle B, two corresponding angles. And the measure of angle C equals the measure of angle AED, also two corresponding angles. Then, according to the theorem, triangle ABC is similar to triangle ADE. And then, the corresponding sides are proportional. Then AD over AB equals DE over BC. and substitute. What is the length of AD? It's 4. The length of AB equals 6. DE equals 4x minus 5. BC equals x plus 5. Again, DE. What is the length of DE? It's 4 minus 5 centimeters. And the length of BC equals x plus 5. Cross multiplication. Then 6 multiply 4x minus 5 equals 24x minus 30. 4 multiply x equals 4x. 4 multiply 5 equals 20. And 24x minus 4x equals 20 plus 30. So 24x minus 4x equals 20x. And the right hand side 30 plus 20 equals 50. And x equals 50 over 20, which equal 2.5 centimeters. Measure of angle C equals the measure of angle E, alternate. And angle B, measure of angle B equals the measure of angle D, two alternate angles. Then triangle ABC is similar to triangle ADE. And we deduce that the corresponding sides are proportional. What is the corresponding sides here? DE, you can write it from the similarity. AB over AD equals BC over DE equals AC over AE. And then we write 5 over DE. It is the length of these two sides, BC and DE, are the two corresponding sides. So the length of BC over the length of DE equals the length of BA over the length of AD as a result of similarity. And make the cross multiplication. So 3 multiply 2x plus 3 equals 5 multiply x plus 4. So 3 multiply 2x, it's 6x. 3 multiply 3 equals 9. 5 multiply x plus 4 is 5x plus 20. And 6x minus 5x, it is equal x, equals 20 minus 9 equals 11. And this is the result of x, the value of x. Important corollaries. Corollary 1. If a line is drawn parallel to one side of a triangle and intersects the other two sides or the lines corresponding them, then the resulting triangle is similar to the original triangle. Here we have in the first figure, if DE is parallel to BC, then we have two similar triangles. The resulting triangle ADE is similar to ABC. And if we draw DE out of the original triangle ABC, we have also two similar triangles, ABC and ADE. Again, here we have the original triangle ABC, and we draw DE in the extension of BA and CA. So DE parallel to BC, then the two triangles are similar. And we must write it in the same order. So triangle ABC is similar to triangle ADE. The same order, because measure of angle B equals the measure of angle D, alternate, and the angle C equals measure of angle E to alternate angles. So next time when you want to prove that the two triangles here the two triangles are similar, then you don't have to prove that these two angles are equal. You don't have to mention that measure of angle D equal B and E equal C. No. You can say since DE is parallel to BC, then triangle ADE is similar to triangle ABC directly. Example 2, in the figure opposite here, ABC is a triangle, ABC is a triangle, D belongs to AB, D belongs to AB, and DE is parallel to BC, line segment DE is parallel to BC, and intersects AC at E. DF is parallel to AC. DF here, line segment DF is parallel to AC, and intersects BC at F. Prove that triangle ADE, this triangle is similar to triangle DBF. Is similar to triangle DBF. First, we have DE is parallel to BC. DE is parallel to BC. Then we can deduce that triangle ADE is similar to triangle ABC. Triangle ADE is similar to triangle ABC because DE is parallel to BC. And this is number 1. Again, with respect to DF. DF is parallel to AC given. Then triangle DBF is similar to triangle ABC. Triangle DBF is similar to triangle ABC. This triangle DBF is similar, the big one, ABC. Then we have triangle ADE is similar to ABC, and ABC is similar to DBF. Then we can deduce that triangle ADE is similar to triangle DBF here, and this is required. Question 3. In the figure opposite, ABC is a triangle. ABC is a triangle. ABC is a triangle. D belongs to AB. D belongs to AB. DE is parallel to BC. DE is parallel to BC and intersects AC at E. AC at E, and AX is drawn to intersect DE and BC at X and Y. The ray AX here is drawn to intersect DE at the point X and intersects BC at Y respectively. State 3 pairs of similar triangles and prove that dx over by equals xe over yc equals de over bc. First, we have DE is parallel to BC. DE is parallel to BC. Then triangle ADE is similar to triangle ABC. This is the first pair of two similar triangles. And also dx is parallel to by. dx is parallel to by. Then triangle ADX is similar to triangle ABY. Also, since XE is parallel to YC, then triangle AXE is similar to triangle AYC. Here we have three pairs of similar triangles. Then prove that dx over by equals xe over yc equals de over bc. For that, since triangle ADE is similar to triangle ABC, triangle ADE is similar to triangle ABC, then AD over AB equals DE over BC. Again, triangle ADE is similar to triangle ABC. We proved it already. Then AD over AB equals DE over BC equals DE over BC. And triangle, since triangle ADX is similar to triangle ABY, then AD over AB equals DX over BY. And we have this ratio is common. AD over AB and AD over AB. We can deduce that the right side here, the two right sides are equal. Then dx over by, dx over by equals dx over by. Again, dx over by equals de over bc here. And this is number one. Since triangle ADX is similar to triangle ABY, then the corresponding sides are proportional. What that mean? We mean that AX over AY equals XD over YB. We write it AX over AY equals XD over YB. Triangle AXE similar to triangle AYC. Then the corresponding sides are proportional. And the proportional is the equality of two ratios or more. Then AX, the first side, over AY, the first side here, equals XE over YC. We have AX over AY and AX over AY. Then the two right sides are equal. We can deduce that dx over by equals xe over xc. Look to 1 and 2. We have dx over by and the left side, dx over by. Then you can deduce that de over bc equals xe over xc. From 1 and 2, we can say that dx over by equals de over bc equals xe over yc. And this is the second required.